Hi, this is your host. In 2021, NASA reported that the average global temperature had reached a new record high for the second year in a row. More than 90% of the increase in heat was absorbed by the oceans, causing rising sea levels. Many parts of the world saw record-breaking heat waves, floods, droughts, and wildfires. And some regions experienced all four in the same year. Climate scientists predicted that this would happen eventually. They just couldn't say when. But as we move into 2022, we might be seeing the beginning of these changes. And this is Crash Course Geography, a study of the Earth's systems and how they interact and change over time, and all the stuff that happens on and to the Earth's surface, which is also called the lithosphere. So in this series, we are going to explore what it means for humans and the natural world when the climate changes and how those changes could affect our planet as physical and human geography now and in the future. So let's start with the basics. What exactly is climate change? Climate is different from weather, which is the short-term condition of the atmosphere at a particular time and place. Climate, on the other hand, describes the typical weather for a region over a long period of time, like 30 years or more. Climate is driven by the amount of solar energy that reaches Earth's surface and is distributed around the planet. And Earth's tilt on its axis and orbit around the sun causes the amount of solar energy to vary over time and space. These variations in solar energy, along with the Earth as systems and components, and the processes that occur within them drive the patterns of weather and climate we experience. But while we have always experienced changes in climate, the changes we're seeing now are happening way faster than any changes that have happened before. So fast, in fact, that it's unlikely that natural processes alone could explain what's happening. Since the Industrial Revolution in the mid-1800s, humans have been burning fossil fuels like coal, oil, and gas for energy. Burning fossil fuels releases gases into the atmosphere that trap heat and cause the planet to warm. And even though this increase in global average temperatures might sound small, it has big implications for all the Earth's systems and for us humans. And while global average temperatures can tell us a lot about overall warming, they don't tell the whole story because temperatures aren't warming up evenly across the planet. The impacts of climate change that we'll explore in this series will vary depending on where you live on the planet. For example, if you live in the Arctic, you might notice the loss of sea ice and the impacts that this has on local plants and animals. Or if you live in Florida, you might see rising sea levels, swallowing beaches, and worry about the safety of your coastal home. As we move through this series, it'll be important to understand the geography of climate change, which includes both the physical geography of how changes vary across space and the human geography of who is affected by climate change and why. To understand the geography of climate change, we need to look at each of the Earth systems separately and then how they all interact with each other. Let's start with the atmosphere. Since the Industrial Revolution, humans have added 4.5 Hiroshima atomic bombs worth of carbon dioxide to the atmosphere every second. Today, about 80% of that extra carbon waste starts to trap more heat in the lower atmosphere, causing the planet to warm. Most of the excess heat goes into the oceans, causing sea levels to rise and ocean currents to shift. The atmosphere also holds water vapor, which is an even more powerful greenhouse gas than carbon dioxide. As the atmosphere warms, it can hold more water vapor, leading to more clouds and precipitation in some areas and longer, more intense droughts in others. Changes in temperature and precipitation affect the biosphere, or the realm of living things on Earth. As temperatures warm, some plants and animals will move toward the poles or up in elevation to find cooler climates. If they can't move quickly enough, they might end up in an area with totally different environmental conditions, or they could go extinct. On the other hand, some species might benefit from warmer temperatures or changes in precipitation and expand their territory. These changes in vegetation can also impact the landscape. For example, hotter and drier conditions increase the frequency and intensity of wildfires, which can completely change the landscape in an area. In a matter of days, flooding can also shape the landscape, carrying soil and rock from one area to another and carving out new river channels. These changes to the biosphere can also affect the geosphere, or the solid part of the earth. As forests get drier, they become more vulnerable to insect infestations and diseases. And when they do, they can die off and release carbon back into the atmosphere. When permafrost thaws, the organic material that is stored in it can also release methane and carbon into the atmosphere. And there's so much carbon stored in permafrost that scientists consider it a carbon bomb. Rising temperatures also contribute to sea level rise, which happens in two ways. First, glaciers and ice sheets melt and add more water to the oceans. Second, warmer temperatures allow more water to evaporate from the ocean, increasing sea level. Higher sea levels mean increased flooding along the coasts. And even if a place doesn't experience more rain, higher sea levels mean storm surges and high tides come closer to the land. Sea level rise also means that groundwater near the coast can become contaminated with salt water, making it undrinkable. So the physical geography of climate change includes all of these changes that affect space, like rising temperatures in the Arctic and rising sea levels everywhere. But the human geography of climate change involves how these physical changes affect humans and what humans do about them. This includes questions like where people will move to escape rising, sea levels or changing climates, and how countries will compete for resources in a world with less water and food. It also includes questions like how current patterns of inequality contribute to the vulnerability of certain communities to climate change, and how we can work toward more equitable solutions. Humans have contributed to the problem, but we are also part of the solution. Scientists predict that global temperatures will continue to rise, and we know that there's no turning back. We can't undo the changes that have already happened, but that doesn't mean that we're powerless. We can reduce our carbon footprint by making changes to our daily lives and demanding changes from our governments. Reducing our carbon footprint isn't enough to undo all the damage that's been done, but it can help slow down the rate of change. Understanding the geography of climate change helps us make better decisions about how to respond to the changes that are already happening and to mitigate the effects of climate change on both people and the planet. Thanks for watching this episode of Crash Course Geography, which is filmed at the Team Sandoval Pier studio and was made in partnership with a digital studio in nature. You want to help keep Crash Course free for everyone forever? You can join our community on a crowdfunding platform.